Pretending to be a Linux power user is hard. You have to act like you remember commands, type some random bullshit, and pray to God you don't delete your entire system. But not anymore. Today, I'm building a functional AI Linux terminal from scratch where you can enter anything and actually get the job done. Let's take this project in two parts. First, we will build a functional Linux terminal, then we will add AI functionalities to it. To make things little bit spicier, let's build it completely using C like a caveman programmer. Let's get started. First, we need an amazing name for our shell program. It should be short and sexy like bash. So I call it SASH, an acronym for Sandy Again Shell. Let's get started. Spin up your VS Code, create a new directory, create a new file, name it sash.c, type hashing root stdio.h, hashing root stdlib.h, int main return 0. Now the hard part is over. Let's take a 10-hour break. Just joking. Looking at this empty canvas for 15 minutes, I realized that if you want to write a shell program, then you need to understand how a shell is actually working. What is happening behind the hoods when you type a command in Linux terminal? Let's learn that first. In my Ubuntu machine, let's enter strace ls. Strace is a command line tool which will help us see the stack trace when a binary is executed. Strace of ls command looks like this. It's slightly intimidating, but let's just ignore everything that we can't understand and focus on only the first line. There you have him, the hero of our show, execve. Execve is a system call. This specific system call is being called with the path to the binary to execute along with two other arguments. First argument is the path to the binary itself, which you can see for yourself. The second argument is the argument vector array, which is basically a two-dimensional array whose last element is null. This is the exact same argv array which you can access from inside a main function of the program that you write on Linux. But who is this third guy? That's none other than environment variables. Every program running inside the shell will get these environment variables inherited, and that is also an array. So the shell program that we are going to develop is responsible for calling execve system call along with these three arguments. That's it. Our plan is simple and straightforward. User inputs a string, we pass the command out of the string, find the path to the binary corresponding to the command, put everything else into argument vector array, and call the execve system call and pray to God. Okay, enough of the boring lectures. Let's start coding with very limited information that we have. First, let's get the command from the user. Let's use getLine function to get the user input. It will stop only when the user enter a enter button. Now, if you print the command from the user, it would be a complete string with command followed by arguments. We need to tokenize it into multiple substrings. Split the string using whitespace character. First token is obviously the command which we should execute. Following tokens are nothing but arguments which we should place inside the argument vector. Okay, now we have commands to execute, but we are left with one problem. How can we find the path to the binary? Don't worry, we have path environment variable for the rescue. Path is nothing but a sequence of paths to directories separated by a colon. This specific environment variable tells the terminal where to look for binaries when the user runs a command. When the user enters a command, shell does a linear search through these paths to find the match and get the path. So let's implement it. Instead of doing a linear search, let's try to access the binary. The logic is simple. We take each path, append it with the command and try to access that file with executable permission. If such a file exists and it has executable permission, access function will say OK and we return the path. In case if binary is not found, we return null and exits printing command not found. Now we have the complete path to the binary to execute and the argument vector. The last missing piece is environment variables. The good thing is that we don't have to do anything on our own. Every program which includes standard library can access a pointer called environ, which stores the pointer to environment variables. No parsing headache, just pass it to the execve function call as the third argument. That's it, we are done. Finally, before calling the execve, it is suggested to spawn execve as a child process. So I added some boilerplate code to achieve this. And finally, it's done. The first part is over. We have almost functional shell program which works similar to bash, csh or any other shell programs. Thanks for watching. Let's see you in the next video. Oh, I forgot something. Yeah, the AA part. Let's do that also. Now we have a completely functional normal Linux terminal with us. Let's add some brains into it. My plan is simple. Intercept the user input and pass it to the AI engine for converting the human readable English into Linux understandable jargons. How can we do that? Almost all LLM providers like OpenAI and Anthropic do have APIs which you can use to send API requests directly into their server without actually needing a UI like ChatGPT. We first have to obtain API key from OpenAI, for which you have to pay some money. Bro, $5 is the minimum deposit? I'm a software engineer, not an OnlyFans model. The hard part is over, the painful part is over. Let's move on to the final hard part. Once we obtain API key from OpenAI, we can use this curl command to get the response from ChatGPT. Curl is a library which facilitates us to send HTTP requests to servers. The command is straightforward. We add some jargons into headers, we place our API key into another header, and for data, we select the model and the query. You hit enter, and after a few seconds, you will get the response in a standard JSON format. In this response, this specific field called text is what we are interested in. So, if we can do this requesting and parsing programmatically through C, we can attach this with Sash and give it some level of intelligence. Let's do that. To achieve this objective, we need help from two other third-party libraries. One is curl and the other one is CJSON. The curl documentation is clean and straightforward. It has lots of examples. I just copy pasted some from their docs and rearranged for our need. And within like 10 to 15 minutes, I was able to say hello world from curl. Parsing the output JSON using CJSON library was also easy. I just copy pasted some code from Geeks for Geeks, Haya Geek, and ChatGPT. It was also straightforward and simple. With the art of copy pasting, we reached till here. We now have two functional parts. One, a fully functional Linux terminal. Two, a program which can do some level of AI things. Now it's just a matter of time that we put them together into one piece. So let's move on to the final hard part. Wait, isn't that what I just did? Oh, let's rename the section to real final hard part. We need to define a structure. This is what the Sash expects when he called the AI engine APIs. Let's define that first. I think this format is more than enough. Sometimes a job might not be doable in one command. So there will be a sequence of commands. That's why I kept it as an array. Description is nothing but a string that can be printed onto the console before executing the commands. And the number of commands is nothing but the length of the array. Let's keep it simple like this for the MVP. Next, we need to instruct ChatGPT to always reply in a specific JSON format only, so that we can pass the response using CJSON and create the structure and return the structure to Sash. Simple. Let us ask ChatGPT itself to create a default prompt which will do this for us. The prompt will look something like this. And I added some CJSON library calls to parse the output and create the structure. In Sash, let's call the AI engine just after we receive the user input and make some modification to basically loop over each commands and execute them. Let's compile it and see how efficiently and buttery smoothly our AI shell is working. Alright, it was really fun building this project. I know this is not the best shell out there. Not all commands are binary. Some are built-in functions like cd, exit, etc. And the terminal programs hugely depends on the running platform. In this video, I was just trying to show how shells are working in Unix-based systems and also how AI shells like warp and shellGPT is working in low level. That's it. I hope you have learned something new. If you are a fan of these kinds of videos, subscribe and share this to more like-minded peoples. Thanks for staying till and see you next time.